Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 5, Reducing Operational Costs in Manufacturing. In a world of rising energy prices and shrinking margins, every inefficiency hurts. In this episode, we explore how smart factories cut costs without cutting corners, using real-time monitoring, data-driven simulations, and AI-based recommendations. You'll learn how to detect energy waste, minimize material losses, and restructure workflows to boost efficiency. We also share how companies in chemicals, food, and logistics have saved up to 20% by rethinking how they use their resources. Factory on Air is powered by DBR77, the AI-enabled platform that helps manufacturers optimize production, energy, and cost all in one place. Let's dive in.
Welcome to The Deep Dive, the show where we really try to take complex challenges, sift through the best insights out there, and bring you the clearest path to understanding. Today, we're plunging into a challenge that, well, it keeps manufacturing and logistics leaders awake at night. I'm talking about the relentless, often kind of invisible pressure of high operational costs. If you're involved in large-scale production, you know the drill energy bills that seem to defy gravity, raw material prices constantly shifting, labor expenses climbing, and then there are those sneaky hidden costs that just bubble up from inefficient processes. It feels less like managing a business and more like fighting a hydra, where you cut off one cost.
Exactly. A hydra, that's a great way to put it. It's this pervasive global challenge, and it often feels like a constant drain.
Only for two more to appear, right?
Yeah. And what's particularly frustrating, I think, is that the traditional cost-cutting methods, often just tightening belts, they simply aren't enough anymore. Not to stay competitive in today's, dynamic and interconnected market, this isn't about mere austerity. It's really about operating with a level of intelligence and precision that just wasn't attainable before. It's about fundamentally rethinking how every single resource is utilized.
Absolutely, and that's precisely what this deep dive is all about. Our mission for you today is to illuminate how things like advanced data analysis and powerful simulations, they aren't just abstract concepts or buzzwords. They're real, tangible tools that can dramatically reduce expenses, maximize how you use your resources, and fundamentally shift your competitive landscape. We're going to zero in on the common culprits behind those soaring costs, explore some cutting-edge monitoring techniques that kind of act as your real-time eye in the sky, if you will. We'll delve into the transformative role of simulations, letting you test changes in a totally risk-free virtual world. And then we'll dive into how a cutting-edge platform like DBR77 pulls all these different pieces together to provide a comprehensive, really end-to-end solution. Our goal here is to give you not just information, but those genuine aha moments, helping you see a clear, actionable path to becoming truly well-informed on this really vital topic. Okay, let's unpack this then. When we talk about high operational costs in a production environment, where do these expenses truly, originate? It often feels like a constant battle, doesn't it? Like you're just bleeding money from 1,000 tiny, often invisible cuts. What are the primary suspects, the main things draining profitability in industrial settings?
You've hit on a critical point there. It often does feel like a battle against forces you can't quite grasp, things you can't quite see. But when you apply a data-driven lens, these high costs really stem from a few core categories, and each one contributes significantly to the overall drain on profitability. The challenge often lies in their hidden nature and, importantly, their tendency to compound on each other.
Okay, so give us the breakdown. Where should companies really start looking first to identify these leaks?
Well, the first, and it's becoming more visible all the time, is energy consumption. Now, we're not just talking about the monthly utility bill, which obviously is substantial enough. We're talking about machines that aren't running efficiently, maybe older equipment. We're talking about equipment left in idle mode unnecessarily, just drawing power for no reason. And also a general lack of optimization during peak hours, when energy prices can really surge. This unchecked consumption directly impacts the bottom line, especially in really energy-intensive industries like, say, chemicals or heavy manufacturing. Imagine a factory floor where a powerful machine, one capable of consuming vast amounts of electricity, is simply humming away in idle for hours just because there's a waiting bottleneck further down the line. That's pure, unadulterated energy waste. It accumulates minute by minute, hour by hour, without producing a single unit. It's like leaving your car idling for an entire workday, just burning fuel pointlessly.
Right. So it's not just about the cost per kilowatt hour itself, but more about how intelligently you're actually utilizing those kilowatt hours throughout the entire production cycle. It's about more than just the utility bill. It's like these inefficient operations are magnifying that bill almost like an invisible tax you're paying.
Precisely. An invisible tax. I like that. Next up, we have material losses. This covers several quite insidious forms of waste that can really sneak up on you. Think about overproduction just creating more than is actually needed right now, which then leads to increased storage costs, potential obsolescence if demand suddenly shifts, and ultimately wasted raw materials. It ties up your working capital and inventory that might never sell or might even degrade while it's sitting there. Then you have direct production errors. These result in scrap material or products that need costly rework. Imagine a scenario where, say, a defect in a single component renders an entire assembly unusable. Or it requires a costly, time-consuming repair that also uses up more raw material. It compounds. And don't forget, improper raw material storage. This can lead to spoilage, damage, or even theft before the materials even hit the production line. These aren't just minor annoyances. They are direct assaults on your profitability. What's truly fascinating here, I think, is how these seemingly small, maybe isolated losses can compound into really substantial financial drains over time. You know, a little bit of scrap here, a bit of rework there, a slight overestimation of demand, and suddenly you're looking at a significant percentage of your material costs, sometimes upwards of 15–20% going straight into the bin rather than becoming a sellable product. It really is a death by 1,000 cuts, especially with the materials, where every wasted gram or unused piece adds up significantly across the board.
That makes perfect sense. I mean, every single piece of material that isn't transformed efficiently into a sellable product is a direct loss, isn't it? A missed opportunity for revenue. What about the way work actually flows through the factory, the processes themselves? Are they often culprits too?
Well, absolutely. That brings us directly to inefficient processes. This covers everything from suboptimal workflows, where materials or components travel unnecessary distances within a plant, adding transport costs and time, to excessively long cycle times. That's the total time it takes for a process to complete from the very start to the very finish. And of course, chronic downtime. This can be due to bottlenecks, poorly planned maintenance schedules, or simply a lack of cohesive operational flow between different stages. These inefficiencies directly impact your throughput, which is the rate at which you're actually producing products, and ultimately your overall production capacity. If your processes are clunky, if they're riddled with unnecessary steps, everything else just slows down. That leads to higher costs per unit produced and reduced responsiveness to what the market actually demands. Human observation, just watching the line, unfortunately, often focuses on the direct work. It misses the subtle wasted movements, the waiting times, or those redundant steps that truly add up in a complex system.
So a long cycle time isn't just about a delay. It's actually about all the resources, the machines, the labor, the energy that are tied up during that extended period, isn't it? It's like waiting in a long queue at the grocery store. You're physically there, consuming space, but nothing productive is actually happening.
Yeah, exactly. A perfect analogy. And speaking of tied up resources, excessive labor costs are another major drain. Now, this isn't necessarily about paying employees too much per hour. It's often more about inefficient work organization, maybe a lack of clear tasks assigned, or critically, idle time for employees. When highly skilled employees are just waiting for materials, waiting for a machine to become available, or waiting for instructions because of a bottleneck upstream, you're essentially paying for unproductive labor. These small pockets of idle time, maybe just 15–20 minutes here and there throughout the day, for several workers, they accumulate into significant financial inefficiencies over a month or a year. And this directly impacts a company's ability to scale efficiently and remain competitive, because your labor cost per unit produced goes up unnecessarily. It undermines your ability to offer competitive pricing or invest in growth.
Right. It's paying for potential that just isn't being realized because of the system around the worker. That must be incredibly frustrating for management, knowing their valuable workforce isn't operating at full capacity due to these systemic inefficiencies. And finally, what about the machines themselves? The backbone of production.
Yes. The last major category we should touch on is unnecessary repairs and breakdowns. This really highlights a critical shift that needs to happen from reactive maintenance, fixing things only after they break, often in a panicked, high-cost scenario, to the absolute necessity of predictive maintenance. A lack of predictive maintenance leads directly to higher service expenses because the repairs, when they finally happen, are often more complex. Sure. You might need expedited parts. It's urgent because a machine has completely failed. And more importantly, it causes costly, unplanned production stoppages. An unexpected breakdown can halt an entire production line. That leads to lost output, missed deadlines, potential penalties for late delivery, and a whole cascade of further costs across the entire operation. It's not just the direct cost of fixing the broken part, it's the ripple effect of lost revenue and wasted time for everyone connected to that line.
So if I'm hearing this right, it's not just the direct cost of, say, replacing a bearing. It's the opportunity cost of the entire line sitting idle, waiting for that fix, not producing any revenue, and potentially letting down your customers. It's the total cost of that disruption.
Precisely. It's the cost of lost production, potentially rush repairs that might not be optimal, maybe overtime pay for catch-up work, and those potential missed customer commitments. All of these things compound and create significant, often untracked financial burdens that eat away at profitability.
Okay, so what does this all mean then for a company that's trying to stay ahead? It really sounds like every one of these areas, energy, materials, processes, labor, and maintenance, is a potential gold mine for savings if you know where to look. And crucially, I suppose, if you have the tools to precisely measure, deeply understand, and then strategically act on that data, it's not just about cutting back anymore, it's about optimizing, about getting exponentially more out of what you already have, essentially transforming waste into opportunity. Now, here's where it gets really interesting, I think. Once you've identified these hidden drains, which, as we discussed, are often insidious and they compound over time, how do you even begin to get a real-time, actionable handle on them? It sounds like a massive undertaking just to monitor everything accurately enough to make a difference.
It does, yeah. And trying to do it manually? Well, it's virtually impossible to do with the necessary precision, especially in complex operations. Thankfully, technology provides powerful, scalable solutions. The foundational tool here, really the starting point, is real-time energy monitoring. This typically involves the strategic installation of IoT, or Internet of Things, sensors on critical machines, sometimes individual components, and even across entire production lines. Think of them as tiny, tireless digital eyes constantly collecting data.
So these aren't just generic sensors like a simple on-off switch. They're specialized devices that can really dig into how much power something is using at a very granular level.
Exactly. These dedicated sensors don't just tell you if a machine is switched on or off. They continuously monitor its precise power consumption. Often they do this by analyzing voltage and current signatures in detail. This allows them to distinguish between different operational cycles of a machine. The subtle hum of idle, the big surge when it does a heavy cut, the gentle draw of a conveyor belt moving. This isn't just a snapshot, it's a constant flowing stream of very granular data. It paints a precise and dynamic picture of energy use across your entire operation. The immediate benefits are pretty significant. You can set up automated alarms for threshold breaches, instantly alerting you if a machine is consuming too much power. Maybe it's due to an unexpected inefficiency, perhaps an emerging fault, or even just operator error. And more importantly, you can analyze consumption trends over time, pinpointing the specific machines or shifts or processes that have the highest potential for savings. Is a particular older machine drawing significantly more power than its newer twin while performing the exact same task? The data tells that story, often revealing these deep-seated inefficiencies that are just impossible to spot manually.
That's incredibly powerful. So you're not just guessing based on an aggregated bill at the end of the month. You're actually seeing the problem as it happens, or maybe even before it escalates into a major issue. But does collecting that much data become overwhelming? How do companies avoid analysis paralysis with, potentially terabytes of information flowing in constantly?
That's a very valid concern, and it's where the correlation and analysis part truly shines. This granular energy data isn't just looked at in isolation. It can be correlated with other operational parameters. Crucially, you can link energy usage directly to production output in real time. This means you can finally answer questions like, is this machine consuming more power per unit produced compared to last month or compared to its sister machine? Or, how does the energy efficiency of line A compare to line B when they're producing the exact same product, maybe under slightly different conditions? This level of precise correlation gives you a true understanding of efficiency, not just raw consumption. And with intelligent analytics platforms, this data is processed into actionable insights, preventing the paralysis you mentioned by highlighting only what's most relevant and requires attention. For instance, the data might reveal that, say, machine X uses 15% more power only when it's fed raw material from supplier B. That could unexpectedly reveal a hidden quality issue or a compatibility problem with that supplier's material that you'd never ever see on a simple utility bill alone. That's a real aha moment.
That really is the eye in the sky you mentioned earlier. You can see everything, connect the dots, and understand the real why behind the numbers. But okay, once you have all this incredibly detailed data, How do you know what changes to actually make without risking production or without investing heavily in some untested solution? That leads us, I think, to the indispensable power of simulation. You can't just go around changing machine layouts or production schedules on a whim, can you? The cost of getting it wrong could be enormous.
Absolutely not. No, that's precisely where simulation becomes a true game changer. It's a major leap forward from traditional trial and error methods. It introduces the concept of a risk-free testing ground for operational changes. Instead of implementing changes directly on your physical production line, which, as you said, could lead to costly errors, significant downtime, maybe even safety issues, or lost production. Simulation allows companies to test various operational scenarios in a completely virtual environment. It's like having a high-fidelity digital sandbox where you can experiment, make mistakes, learn, and optimize without any real-world consequences or financial risk whatsoever.
A digital sandbox for your entire factory. I love that analogy. It makes it very clear. So what kind of concrete scenarios can you actually model and test in this virtual world to drive cost reduction? Give us some examples.
Well, the possibilities are quite extensive, and they directly tackle the cost drains we were just discussing. For instance, you can test how changes in a machine's operation sequence, or its speed, might affect overall energy consumption. Would running certain machines in a different order, or maybe grouping specific tasks together, actually save power without compromising the final output? You can model that precisely. Or, let's say you're considering altering a logistical layout within your factory or warehouse. You can analyze the precise impact on internal transport fuel consumption. Would moving this storage rack over here, or that assembly line slightly there, actually reduce the distance your forklifts travel, thus saving fuel and labor time? You can simulate that material flow optimization to identify and eliminate bottlenecks before moving a single piece of physical equipment.
So you're essentially measuring the what if before the what is even exists in the real world. You're predicting future states based on potential changes.
It's exactly predicting future states. You can also analyze how different maintenance strategies might impact costs and uptime. For example, shifting from time-based preventative maintenance to condition-based predictive maintenance. How that affect your service costs over, say, a year. How much uptime could you gain? You can even simulate the introduction of completely new equipment or automation, understanding its impact on throughput, labor utilization, energy needs, everything before you buy it. The crucial takeaway here is that simulations enable the selection of the most economically viable scenarios before committing any real resources, time, or capital. This foresight is invaluable. It moves decisions from gut feeling or best guess, which, let's be honest, are often suboptimal in complex systems, to mathematically proven optimizations. It reveals hidden interactions and cascading effects that are simply invisible to human intuition or even simple spreadsheet analysis. This raises an important question, doesn't it? Imagine the profound impact of being able to predict outcomes, identify bottlenecks with certainty, and optimize complex processes without ever touching a physical machine or disrupting your ongoing operations. That's the profound power of simulation. It transforms strategic decision-making from what can feel like a gamble into a calculated, data-driven choice. It's almost like having a time machine for your factory floor.
That vision is incredibly compelling. It really does move you from merely reacting to problems after they happen to proactively preventing them, optimizing for efficiency at literally every turn. And this isn't just theoretical, is it? Or some distant future concept. We've seen real-world success stories. Companies are already leveraging these capabilities to achieve significant cost reductions, right?
Absolutely. The S1E5 source material you mentioned earlier provides some excellent concrete proof points that really bring this to life. For example, there's a case of a chemical plant that managed to achieve a significant 15% reduction in energy consumption. And they did this simply by optimizing the schedule for their equipment. Now, this wasn't a blanket energy cut across the board. It was achieved by leveraging real-time data from their IoT sensors to understand exactly which equipment was most energy intensive, when it was truly needed, and then using simulations to determine the most efficient sequencing and timing for their operations. This helped them avoid unnecessary idle power draw and also minimize usage during peak price hours.
15%. That's a huge chunk, especially for an energy-intensive industry like chemicals, where energy bills can be absolutely astronomical. That's not just savings, that's a fundamental competitive advantage, isn't it? Freeing up capital for other investments.
Precisely. It's a direct boost to the bottom line. Another compelling case study is a food factory. They realized a remarkable 20% reduction in material losses. And again, this wasn't achieved by just implementing stricter quality control at the end of the line. It came from a deep analysis of their real-time production data. By correlating material input with finished product output, they pinpointed specific areas of scrap and rework. But more critically, they managed to curb overproduction. They moved from a just-in-case approach, producing extra just to be safe, to a much leaner just-in-time model. This greatly minimized waste from things like spoilage, obsolescence, and unnecessary storage, directly impacting their bottom line.
Right, so they basically stopped making more than they actually needed at that moment, which cut down on storage costs, spoilage risk, and the raw material cost itself. It's brilliant, a classic lean manufacturing principle, but supercharged by real-time data.
Exactly. And one more from the logistics sector. A logistics firm saw an impressive 18% decrease in internal transport costs. This was achieved through intelligent route and warehouse optimization. They likely used simulation tools to analyze forklift paths, figure out the optimal storage locations for frequently accessed items, and improve loading and unloading efficiencies. By minimizing those empty runs and optimizing travel distances within their facilities, they dramatically reduce fuel consumption, wear and tear on their vehicles, and the associated labor time. These are not minor tweaks we're talking about. These are substantial double-digit reductions across critical operational areas.
Yeah, those are genuinely substantial double-digit reductions. They really prove the effectiveness of these data-driven, simulation-powered approaches. It's clearly not just about what's theoretically possible, it's about what's actually being achieved by companies right now, translating directly into enhanced profitability and competitiveness.
Okay, so we've talked about the pervasive problem of these hidden operational costs and the incredible power of monitoring and simulation as real game changers. Now, how does a platform like DBR77 manage to tie all these different pieces together? How does it deliver on this promise of real savings and operational transformation? What's their foundational vision for this comprehensive ecosystem they've built?
Well, DBR77's core mission, fundamentally, is to be a modern, truly comprehensive digital transformation platform. It was specifically designed from the ground up to address those key pain points: the rising operational costs, the nagging lack of data precision that holds companies back, and the limited adaptability that many industrial production and logistics firms face, particularly those maybe stuck with older legacy systems. Their approach is genuinely holistic. They integrate the Internet of Things, digital twin technology, artificial intelligence, and an intelligent marketplace, all into one cohesive, interoperable ecosystem. It's about providing a single integrated solution, not just a collection of disparate tools that don't necessarily talk to each other easily. They aim to be the single source of truth for your entire operation.
That sounds incredibly ambitious, bringing so many cutting-edge technologies together under one roof like that. Let's try and break down how each of those pillars contributes, maybe starting with the digital twin. For many people, that still sounds almost like science fiction. What exactly is DBR77's digital twin, and how does it help companies cut costs in practice?
Right, it can sound futuristic, but it's very practical. The DBR77 digital twin creates a virtual and mathematical model of a real production plant or logistics center. Think of it as a living, breathing, high-fidelity digital replica of your entire physical operation. But it's far more than just a static 3D model. It combines advanced 3D simulation capabilities with real-time data integration streaming in from your IoT systems. This allows for continuous monitoring, deep analysis, and precise optimization of pretty much every single process within your facility, reflecting the current actual state of your physical plant in real time.
So it's not just a static blueprint or a model you build once. It's constantly updated with live data from the physical world. It creates a dynamic, mirrored reality.
Precisely. That dynamic mirroring is absolutely crucial for cost reduction because it empowers users to test various scenarios, identify bottlenecks accurately, and predict the exact impacts of proposed changes without ever disrupting ongoing physical operations. You can simulate putting in a new production line layout, trying a different machine schedule, maybe a shift in material flow, or even the impact of adding a new robot. And you see the exact financial and operational consequences play out in the virtual environment first. It allows you to model those what-if scenarios for energy consumption, material usage, labor efficiency, everything. It truly is that low-risk sandbox for high-stakes decisions we talked about. And it directly contributes to reduced operational costs and increased efficiency by eliminating costly trial and error in the real world. You solve problems and optimize processes digitally before you ever spend a dollar or stop a production line in the physical world.
That makes perfect sense. It really is like having a perfectly accurate flight simulator for your factory, isn't it? Where you can crash as many times as you like virtually without any real consequences, learning and optimizing before you ever commit to the real thing. And the data feeding that incredibly realistic simulation comes from their IoT solutions, I presume.
Exactly. That's the connection.
DBR77 provides its own dedicated sensors and systems for collecting operational data from machines and processes right across the plant. And this isn't just about general data collection. It enables precise, real-time measurement and analysis of every parameter that matters, things like temperature, pressure, machine uptime, actual power consumption patterns, material flow rates. These sensors capture that energy fingerprint we talked about earlier, providing a level of granular detail that traditional data collection methods like manual entry or infrequent checks simply cannot achieve.
Okay, so they're not just relying on integrating with whatever sensors might already be there, they're actually providing the hardware for potentially better, more accurate data collection from the start. What's the direct cost benefit there for, our listener thinking about this?
Well, the data itself identifies inefficiencies that would otherwise remain completely hidden, or maybe would take weeks of manual observation and analysis to even uncover. It helps optimize workflow by showing you exactly where delays or bottlenecks are occurring, not just in theory based on a process map, but as they actually happen in real time, and allows you to forecast production needs with much greater accuracy, significantly reducing instances of costly overproduction or equally costly underproduction leading to missed orders. This all leads to increased data accuracy across the board, a significant reduction in the time needed for manual analysis, and lower information acquisition costs overall. Ultimately, this translates to better, more agile operational management and faster, more accurate decisions, which always leads to substantial savings and improved profitability down the line. It's about turning raw data into an immediate competitive advantage.
Right, that's the backbone then, the raw material for all this intelligence. But DPR77 also has something called a marketplace, which sounds quite unique for an industrial platform like this. How does that fit into cost reduction, especially when we're talking about potentially big automation investments?
Ah, yes, the DBR77 Marketplace. It is truly an innovative environment, and it's definitely one of their standout features. It acts as a central hub, essentially a one-stop shop, connecting businesses with leading automation technology providers and integrators from all over the world. So instead of your team individually searching for suppliers, vetting them, sending out RFPs, and collecting bids, which is a huge time sink, you can quickly and transparently compare offers from a vast network. They have over 800 technology suppliers and 600 integrators on the platform now, making it the largest platform of its kind globally. And what's more, it's powered by DBR77's AI. This AI provides data-driven recommendations based on sophisticated cost-benefit analyses, helping you choose the most suitable and cost-effective solutions for your specific needs. It considers factors like ROI, integration complexity, even vendor reliability history. Now, if we connect this to the bigger picture, this isn't just about finding a supplier a bit faster. It's about fundamentally revolutionizing the entire automation procurement process, which historically is notoriously slow and often inefficient. Think about it. A standard automation or robotization purchase and implementation project, from the initial planning stages right through to having it fully optimized on the factory floor, can take an average of 25 months. That's over 2 years of lead time.
25 months for one project. Wow, that's an eternity in today's fast-moving market. That must be a huge drag on responsiveness and innovation for companies.
It absolutely is. But using the DBR77 Marketplace, this time can be dramatically cut, potentially in half. And here's the really striking statistic from the S1E5 source. Companies can save a whopping 30% of cost at the purchase and implementation stage alone. This isn't just about speeding things up. It's about dramatically reducing the direct costs associated with those extended project lead times, the often complex vendor selection process, and maybe the risk of making suboptimal choices under pressure. And interestingly, the integrators on the platform also benefit significantly because it cuts down on their bidding process time by several weeks, allowing them to focus more on execution and less on sales overhead. It really is a win-win for the entire value chain.
30% savings and potentially cutting implementation time in half for major automation projects. That's not just cost reduction. That sounds like a competitive earthquake. That frees up massive amounts of capital and dramatically speeds up innovation cycles. What role does AI play across the rest of the DBR77 platform beyond just the marketplace's recommendations?
Well, DBR77's AI systems are really the brains analyzing the vast amounts of data that are flowing in from both the IoT sensors on the ground and the simulations running in the digital twin. And this isn't just about crunching numbers passively. It's about actively identifying subtle inefficiencies that human eyes, even expert ones, would likely miss. It's about predicting potential equipment failures before they happen. and suggesting optimal courses of action in real time. It's essentially like having your own virtual data scientist and operations consultant, working 24/7, constantly looking for ways to improve and optimize your operations.
So it's not just reporting problems after the fact, but it's actively suggesting solutions and improvements proactively.
Exactly. The platform includes a built-in AI assistant that acts very much like a virtual lean consultant. It provides real-time, data-driven recommendations specifically for cost reduction and process improvements. For example, it might suggest adjusting a specific machine's idle time parameters during certain hours to save energy based on predicted production flow. Or it might suggest resequencing tasks on a particular production line to minimize material waste and shorten cycle times based on simulation results. It might even alert you to a subtle anomaly in a machine's vibration signature, predicting a potential bearing failure days or even weeks in advance. This allows for planned, far less costly maintenance instead of a catastrophic failure. Machine learning, which is a subset of AI, also plays a crucial role here. It's used to develop predictive models based on vast amounts of historical data and even synthetic data generated by the platform. This allows for dynamic strategy adjustment and increasingly automated decision-making for optimal performance over time. Synthetic data, for example, is really critical for training models on rare but potentially critical events, like specific types of equipment failure, ensuring the AI is robust and reliable, even when real-world data for those events is scarce.
Okay, so from the shop floor, monitoring machine health predictively, right up to the executive suite, getting insights on strategic investments, AI is providing genuinely actionable intelligence. And I understand DBR77 also has dedicated tools specifically for the financial side of things, for CFOs and procurement teams. This sounds like a truly top-to-bottom solution.
That's right, they've considered the whole workflow. For CFOs, DBR77 provides dedicated tools designed for comprehensive cost analysis of automation and robotization investments. This includes full transaction transparency across the marketplace, detailed ROI analysis of potential investments before you commit, and precise budget planning tools. And all of this is supported by AI for more accurate assessment of the total implementation cost, not just the sticker price. It provides the financial visibility and predictive power needed for truly strategic investment decisions, helping move away from guesswork towards data-backed projections for capital allocation.
Right. It's about making sure every dollar spent is the smartest dollar spent, with full visibility into its likely return, eliminating a lot of the guesswork that often plagues these large capital expenditures.
Exactly. And for the procurement departments, the platform is equally powerful. It supports them through automatic offer comparison from vendors in the marketplace, objective supplier reliability assessment based on historical performance data within the platform, and complete cost transparency across the entire purchasing process. This significantly accelerates purchasing processes and automation projects, ensuring they get the best value without compromising quality or reliability and drastically cutting down negotiation and vendor selection times.
So it really creates a seamless, data-driven experience. From the initial technical assessment of an operational problem, all the way through to simulating potential solutions, buying the right technology efficiently, and then managing the financial impact transparently, all integrated into one ecosystem. It really does sound like they've covered the entire life cycle of operational improvement.
And that ties directly into DBR77's holistic process optimization capabilities, bringing it all together. The platform extensively supports optimizing both production and logistics processes. It does this through automatic measurement of every step, material flow optimization across the entire plant, and continuous operational efficiency analysis. The digital twin, as we discussed, is absolutely key here. It helps simulate potentially endless scenarios to reduce downtime, shorten order fulfillment times, and increase overall plant efficiency. It even integrates concepts like value stream mapping, which, for those perhaps unfamiliar, is traditionally a powerful visual tool used to manually map every step of a product's journey, from raw material to customer delivery, identifying waste at each stage. But DBR77 elevates this concept by providing dynamic process analysis. It allows for continuous monitoring and identifies bottlenecks in real time, rather than relying on just static mapping, which often becomes outdated the moment it's created. It truly enables a culture of continuous, data-driven improvement across the organization.
It really is an end-to-end ecosystem, isn't it? From sensing the problem on the factory floor to simulating optimal solutions, buying the right tech efficiently, managing the financial impact, all integrated and continuously optimizing itself? Wow. Okay, this all sounds incredible, honestly. A real potential game changer for industrial companies battling these rising costs we talked about. But transforming traditional operations with advanced technology like this usually comes with a fair share of hurdles, right? Companies often face significant resistance or complexity, or sometimes simply a lack of understanding. What are the common concerns you hear about, and how does DBR77 actually navigate that digital frontier, making it accessible and effective for real-world businesses?
That's a very practical and absolutely critical question. Implementing such advanced solutions can indeed seem daunting, especially for firms maybe deeply rooted in traditional practices or with complex existing systems. DBR77 seems to have anticipated these challenges pretty well and has built specific approaches to overcome them, essentially turning potential roadblocks into competitive advantages for their clients.
Okay, let's start with what might be the biggest hurdle for many, the perceived high entry barrier for traditional firms. If you're a company that hasn't deeply embraced advanced technology yet, where maybe manual processes are still king, things like digital twins and IoT might seem overwhelming, too complex, or just too expensive to even consider starting. How does DBR77 address that initial intimidation factor?
Yeah, the problem is exactly as you describe it. Sometimes a lack of awareness of the real benefits, combined with a fear of technical difficulties or massive upfront cost, can significantly slow down or even prevent adoption altogether. DBR77's approach here seems centered on human-centric design. They prioritize intuitive use and accessibility. Apparently, most core functionalities are accessible after just a few hours of basic training. This aims to eliminate the need for companies to hire expensive external IT experts or undertake lengthy, costly internal training programs just to get started. On top of that, DBR77 invests heavily in extensive educational materials. Think real-world case studies showing tangible results. The DBR77 Academy, which offers structured learning path and regular webinars explaining specific features or use cases. This drastically reduces the often underestimated soft costs of training and integration, allowing for much more rapid adoption and a quicker path to seeing tangible value. It's designed so you can start small, prove the concept, and then scale up as you get comfortable.
That's smart. Making it easy to use and providing clear guidance definitely lowers that initial intimidation factor. It makes advanced tech feel less like climbing a mountain and more like walking up a gentle slope. But what about large established organizations, the ones that already have deeply entrenched IT infrastructure, complex ERP systems, manufacturing execution systems, MES, warehouse management systems, WMS? Integrating new digital solutions there can be an absolute nightmare, right? Leading to massive projects and unforeseen costs.
You're absolutely right. Complexity in large organizations is a significant concern. It can lead to higher initial costs, project overruns, and painfully long implementation times, derailing the whole initiative. DBR77 tackles this quite cleverly by being a browser-based platform. This is a key technical point. It means no modification of the client's existing IT infrastructure is required to use the core platform, which is a huge advantage. Integration with those existing systems like ERPs, MES, or WMS is facilitated by a carefully designed API that's an application programming interface. Essentially, it allows DBR77 to talk seamlessly with your existing systems without disrupting them or requiring complex custom coding. And importantly, DBR77's dedicated IT support team actively assists clients in these integration projects, minimizing both the time costs and, critically, the risks of downtime for your core operations. It's designed for seamless connection, not a disruptive rip-and-replace approach, which saves immense time and resources.
Okay, so it's designed to play nicely with what's already there, acting more like an intelligent overlay rather than a disruptive overhaul. That must be a huge relief for IT departments and operational managers alike. But the effectiveness of all this AI and the simulations, it relies heavily on data quality, doesn't it? What if a company's existing IoT infrastructure is poor, or maybe they have limited sensors leading to unreliable or incomplete data? Isn't that a critical vulnerability for a platform like this?
That's absolutely a critical point, yes. Dependence on data quality is a real challenge across the industry. Poor or insufficient IoT infrastructure inevitably leads to unreliable results from simulations or AI, which then, quite rightly, discourages further investment. Garbage in, garbage out, as they say. DBR77 addresses this potential weakness by offering not just the software platform, but also hardware. They provide their own dedicated high-precision sensors and a comprehensive data collection support system. This aims to ensure high-quality, accurate, and precise data collection from the very beginning, acting as a reliable foundation for everything else. Furthermore, they have a standard database structure that allows initial simulations and analysis, even if you start with limited live data from your plant. Now, while the precision might be lower initially compared to a fully instrumented plant, it's often sufficient to identify core problems and suggest immediate areas for improvement, providing actionable insights and demonstrating value right from day one. It's about achieving progress over perfection initially. building confidence as the data quality gradually improves over time.
Right, so they can start seeing value and making better decisions even before their data collection infrastructure is absolutely perfect. That sounds like a great way to prove ROI quickly and build that crucial internal buy-in for wider adoption. Okay, what about the elephant in the room? Competition. There are large established tech players like Siemens, ABB, Schneider Electric out there. They're giants in this industrial digitalization space. How does a company like DBR77 effectively compete with that kind of market power and brand recognition?
Indeed, the strong market position of those giants could seemingly slow DBR77's expansion, no doubt. However, DBR77 seems to have adopted a very strategic and, so far, effective approach. They initially focused heavily on small and medium enterprises, SMEs. This is a vast segment of the market that is often overlooked and arguably underserved by the larger providers whose solutions might be too complex or expensive for smaller firms. DBR77's simplified implementation model, that human-centric design we talked about, and the potential for fast ROI quickly attracted these businesses who needed agile, affordable solutions. What's interesting, though, is that this success with SMEs has also naturally started attracting larger corporations. These bigger players are appreciating DBR77's flexibility, its simplicity, and perhaps most importantly, its significantly lower subscription-based starting cost. Unlike some competitors whose full implementations can run into hundreds of thousands or even millions of euros up front, DBR77 offers a much more accessible price point and allows for gradual scalability.
This really sets them apart as a potentially more agile and cost-effective alternative, even for some enterprise-level deployments.
That's a clever strategic play. Targeting an underserved market initially, but then proving the value proposition so compellingly that the bigger players start taking notice. Makes sense. But industrial clients, they can be notorious for long decision cycles when it comes to adopting new technology, right? There are committees, extensive tests required, lengthy ROI analyses needed for budget approval. How do they speed that process up?
Yes, the problem of long decision cycles in industry is very real. It affects sales cycles, negotiation timelines, and ultimately, it slows down the pace of innovation for the client company itself. DBR77 seems to tackle this by strongly emphasizing pilot projects. They encourage clients to test the solution on a small scale, first, perhaps, just on a single machine or one production line. This allows the client to rapidly verify the effects and calculate a tangible, real-world ROI within just weeks or maybe a few months, not years. The subscription model further helps here by avoiding those high upfront capital costs. This significantly accelerates decision-making because the entry barrier is much lower, and the high ROI can be demonstrated quickly and convincingly. This approach often leads to quicker approval for full implementation after a successful pilot, as the value is clearly proven internally and the financial commitment is spread out over time, making it easier to budget for.
So it's effectively a try before you buy approach, but one that shows immediate, tangible value based on their own data. That's incredibly hard to argue with in a business context, I imagine. And for these complex digital and automation solutions, you also need a strong integrated partner network for successful implementation, don't you? A lack of good partners can severely hinder success, especially for companies that don't have deep internal expertise in these areas.
Absolutely. A robust ecosystem of reliable technology providers and skilled integrators is absolutely vital for successful implementation and, just as importantly, ongoing support. The DBR77 marketplace directly addresses this need. As we mentioned, it boasts over 800 technology suppliers and 600 integrators, making it, as we said, the largest platform of its kind globally. This creates a true one-stop shop, ensuring clients have rapid access to pre-vetted specialists and solutions without the client having to spend months searching far and wide, vetting potential partners, and contracting individual vendors separately. This network is also continuously growing, providing swift access to qualified partners who are already familiar with the DBR77 platform and how to integrate it effectively, which streamlines the entire project lifecycle significantly.
That's an impressively comprehensive network they've built. It really sounds like they've thought through almost every single potential roadblock a business might face when trying to adopt these advanced digital solutions, and systematically tried to turn those potential problems into key advantages for their clients. But for all this capability, companies ultimately need to see a clear, rapid return on their investment to justify ongoing subscriptions, right? What about those direct ROI requirements?
Yes, industrial firms, quite rightly, demand fast, tangible savings to justify subscriptions. ROI is king. DBR77's approach here is multifaceted. Firstly, the low initial cost, thanks to the subscription model, inherently contributes to a rapid ROI, often achievable within months rather than years. Beyond that fundamental pricing structure, The integrated marketplace helps clients select the truly optimal solutions and technologies for their specific needs, precisely calibrated for their unique operational context. This significantly shortens implementation time compared to traditional methods. This combination dramatically increases the likelihood of quickly seeing those tangible effects we talked about, like that 15% energy saving or 20% material reduction, and proving the immediate financial value of the platform very clearly. The speed of realization seems to be a key differentiator for them.
Okay, and finally, the technology itself. AI and digital twins are evolving incredibly fast. How does DBR77 ensure its platform doesn't become stagnant and actually remains at the cutting edge in such a dynamic environment? That must be a constant challenge.
That's a crucial challenge for any tech platform today. The absolute necessity of continuous development just to maintain a competitive edge, let alone lead. DBR77's strategy here seems to be leveraging its growing user base. They continuously collect vast amounts of real and synthetic operational data from their clients' operations, anonymized of course, and from their own internal simulations. This massive, ever-growing data set serves as an excellent proprietary training base for their AI algorithms, ensuring they remain cutting-edge and highly relevant to real-world industrial challenges. Additionally, that direct collaboration with technology providers and integrators within their marketplace ensures they have constant updates on hardware advancements and new technological solutions coming to market. This, coupled with advanced spatial analysis functionalities built into the platform, helps keep DBR77 at the forefront of innovation. They appear to be perpetually learning and adapting, which is absolutely vital in this rapidly evolving tech landscape.
It really does sound like they've systematically engineered solutions for almost every single potential point of friction and uncertainty, systematically transforming common industry challenges into tangible advantages for businesses, ensuring they stay not just current, but truly ahead in a rapidly evolving tech landscape. Okay, so we've dissected the problems, we've explored the digital arsenal of monitoring and simulation, and we've seen how DBR77 has architected this comprehensive, integrated solution to address these challenges head-on. But what does all this mean for the big picture? How do these deep operational savings truly translate into a lasting, significant competitive edge for a company? What's the ultimate end game here, really, beyond just saving money month to month?
Well, the end game is potentially profound transformation, not just incremental improvement. These operational savings have a multi-layered ripple effect that can fundamentally reshape a company's competitive standing in the market. It allows them to not just survive in tough times, but truly thrive and potentially lead. But before we maybe get to that strategic impact, it's probably worth quickly recapping the actionable blueprint from that S1E5 source material. The practical steps companies should probably follow as they start on this journey.
Yeah, good idea. Lay out those practical steps for anyone listening who's thinking, okay, this sounds great, but where do I actually start? Give us that concise blueprint for action.
Certainly. First step, audit your current energy and material consumption. And this means going beyond just looking at simple utility bills. Use more specific diagnostic tools, maybe sensors, to really understand where every kilowatt hour and every gram of material is actually going. You simply can't improve what you don't accurately measure first. Second, based on that granular audit, identify the largest sources of waste. Don't just look at the symptoms. Try to dig for the root causes of that inefficiency. Why is that machine idling? Why is there so much scrap here? Third, implement real-time consumption monitoring, as we discussed earlier. Use those IoT sensors to create that continuous feedback loop, turning static historical data into dynamic, actionable insights. Fourth, simulate alternative work organization scenarios. Use tools like the digital twin to test potential improvements virtually, tweaking layouts or schedules without risking real production or spending capital up front. Fifth, and this is crucial, educate employees on cost optimization practices. Technology is a powerful enabler, absolutely, but human engagement and building a culture of continuous improvement are vital for sustained success.
Get buy-in from the shop floor. And finally, step 6, regularly review and update your saving strategies. Because market conditions change, technologies evolve, and even your own internal processes are always shifting slightly. It needs to be an agile, ongoing approach to optimization, not a one-off project. Now, these steps, while they sound practical and maybe even straightforward on paper, their effectiveness truly hinges on the ability to access and analyze the right granular data, which, as we've discussed, platforms like DBR77 facilitate with immense power and precision. Without that detailed, real-time data and the ability to accurately simulate outcomes, these steps are far, far less effective, often leading to suboptimal results or completely missed opportunities for significant savings.
Got it. So that's the blueprint. But DBR77 provides the advanced tools, the high-tech toolkit, to execute that blueprint with surgical precision and much greater confidence. Okay, so back to the strategic impact. What's the ultimate result of achieving these deep savings across your operations?
Well, the transformative impact is multi-layered, as I said, and it creates a powerful virtuous cycle for the business. First, and most directly, you see dramatically increased margins and profitability. It's simple math. By reducing operating costs, more of your revenue flows directly to your bottom line, making your business inherently more lucrative and financially robust. For example, a 10% reduction in overall operational costs often translates to a much larger percentage increase in net profit, sometimes 20, 30% or even more, depending on your existing margin structure.
Right.
It has a leveraged effect.
Which then allows for what in terms of competing in the marketplace?
Well, it directly enables competitive pricing. If your production costs are significantly lower than your competitors, you gain unparalleled flexibility. You can choose to offer more attractive prices to customers while still maintaining or even increasing your desired profit margin. This makes your products more appealing, helps you gain market share, often without sacrificing quality, and it puts immense pressure on less efficient competitors who can't match your cost structure.
That sounds like a dream scenario for sales teams and market strategists. What about resilience, especially in today's often unpredictable global economy?
Absolutely. Lower operational costs build greater resilience to external shocks. Think about things like fluctuating raw material prices, sudden energy cost spikes, or even unexpected supply chain disruptions. When your base costs are optimized and lean, these external volatility factors have a much less severe impact on your overall profitability. You're better insulated from market instability, allowing you to weather economic storms much more effectively than your peers might be able to. It's like building a stronger financial immune system for your business.
And then presumably there's the ability to invest back into the business into the future.
Precisely. The freed up financial resources from cost optimization don't just have to sit there as increased profit, although that's nice too. They become investment capacity. This crucial capital can then be reinvested strategically, maybe into research and development for new products, or adopting even more cutting-edge technologies like advanced robotics or AI-driven quality control. Perhaps expanding production lines into new geographic markets, or even making strategic acquisitions of competitors or complementary businesses. It fuels growth, it accelerates innovation, and it positions you for future leadership, not just current survival.
So it really elevates the conversation beyond just surviving, towards actively thriving and shaping the future of your industry.
It's exactly. All these factors combine higher margins, competitive pricing, greater resilience, increased investment capacity, lead inevitably to a strengthened market position. Whether you're competing locally or globally, a company that consistently optimizes its costs, offers compelling value to customers, and has the capacity for continuous innovation will naturally gain a stronger foothold, attract more customers, and become a recognized leader in its industry. This isn't just about survival in a competitive landscape anymore. It's truly about setting the pace, driving innovation, and actively leading in a dynamic, ever-changing market.
What an incredible journey we've taken today. We started by peeling back the layers of those pervasive, often quite hidden operational costs that plague so many manufacturing and logistics firms, everything from energy waste to material losses to inefficient processes, unproductive labor time, and those costly unexpected breakdowns. We then explored the powerful digital arsenal that's now available. The crucial role of real-time IoT monitoring acting as your eye in the sky, providing that essential granular data, and the truly transformative power of simulations, allowing you to test complex changes completely risk-free in a virtual sandbox, essentially, giving you that time machine for your factory we talked about.
And then we saw how a comprehensive platform like DBR77 manages to tie all these advanced technologies together, integrating IoT, the digital twin, AI, and that revolutionary marketplace into one unified functioning ecosystem. It's clearly about much more than just collecting data. It's about turning that data into genuinely actionable insights, driving massive efficiencies, and dramatically accelerating major initiatives like automation projects, cutting both the costs and the implementation time significantly. It really is about enabling a sustainable strategic advantage.
Ultimately, as you said, it's not just about saving money in the short term, although that's obviously important. It's about building a more efficient, incredibly resilient, and fiercely competitive enterprise for the long haul. It frees up those critical financial resources for future innovation. It strengthens your market position against competitors, and it gives you crucial agility and flexibility in what seems like an ever-changing economic and technological landscape.
Yeah, it's about moving beyond simply reacting to costs and market pressures towards proactively architecting a more profitable, more sustainable, and truly future-ready enterprise, one that can genuinely lead its industry forward.
So, as you, our listener, think about your own operations, your own specific challenges, maybe take a moment to imagine a future. Imagine a future where every single operational decision, from the smallest adjustment on a machine setting to a major capital investment in a new line, is informed by perfect, real-time data and validated by simulation. Imagine a world where waste energy, materials, time is minimized to an absolute fraction of what it is today, and your operational potential is maximized to its fullest extent. What new innovations, what breakthrough products, what sustainable practices could your industry unlock if operational costs were no longer the primary constraint, but instead became an optimized foundation for ambitious growth?
It's a powerful thought, isn't it? One that really shifts the focus from just managing limitations day to day to enabling truly boundless possibilities for growth and innovation in the future.
For those of you intrigued by the possibilities we've discussed today, whether you're currently battling high energy costs, struggling with material waste, or looking to optimize your production lines for better throughput, there's clearly a wealth of further information out there to explore. You can delve deeper into the specifics of digital twins, learn more about advanced IoT applications in your sector, or explore the specifics of how integrated platforms like DBR77 might function for your unique operational needs and challenges. The future of industrial transformation is not just coming. In many ways, it's already here, and it's ripe for exploration. We hope this deep dive has given you a clearer map for navigating that exciting journey. Thank you for joining us.